bisectors of triangles. We're going to talk about different types of bisectors. I'm going to actually talk about a different bisector first than the book is going to talk about. I want to talk about some properties of angle bisectors. Okay? Angle bisector is a ray or something that cuts an angle in half. What does AD do?
Bisects.
Bisects it. Meaning this is congruent to what? That. Everyone be in agreement?
Yes.
Then we should know what an angle bisector is. Now there are some special things that happen here. The distance from the bisector to the sides of the angle it bisects will always be equal. What throws a lot of people for a curve here, or gives people problems, is understanding when you're talking about the distance from a line to a point, how do we measure that? Now I'm going to get a separate sheet of paper out. I do not want you to draw this. I just want you to pay attention. There's the ground. Here's a plane flying. When they talk about we're flying at an altitude of 30,000 feet. Agreed? What in the world are they saying? How what? High they are. But here's the thing. When they say that, are they saying they're 30,000 feet from the airport over here?
No.
Are they talking about the distance just a little bit back?
No.
Are they talking about the distance to where you're going?
No.
When they say altitude, what are they talking about?
Straight up and down.
Straight, okay, there's the word. I heard the distance what?
Straight up and down.
Straight down. When they say altitude. Agreed? That's what they're talking about, the distance, straight down. Like I said, don't draw this, just pay attention. In essence, isn't this plane, when they're doing that, they're measuring from a point on the plane, right?
Yes.
To a line, which is the ground? Would you agree with that? What does straight down mean, you think, in geometry?
Undefined.
No. Why is, oh, let me ask you this. Why is this line not straight down and this one is? What is the difference?
The angle.
distance.
The angle.
Huh?
The angle.
The angle in which I'm pointing down?
Slope.
Or well, what, when you look at these two right here, does that angle look different than that angle?
Yes.
If I went more over here, does that angle even look different than the other two?
Yes.
And as I go out to here, what happens to this angle? It keeps getting what?
Wider.
Bigger. Yeah. That angle keeps getting bigger. But at only one point and then as you go in closer, it gets what? Smaller, and then it starts getting what? Bigger again. So what do you think straight down means again?
The smallest
Well, yeah, but what is that angle?
angle.
No.
It's on the angle.
What angle do we have right here?
90.
Is it when we talk about being straight to something, it ends up being 90 degrees?
Yes, sir.
Isn't that what straight down means?
Yes.
90 degrees? That's what straight down means. So when we talk about how do you measure the distance from a point to a line, we always measure that along a right angle because that's the straightest way to it. That's the fastest way to it, isn't it? If I went, as this angle gets bigger, it's a little bit longer or a little bit farther to get to that, isn't it? If I go straight to it every time, it's going to make a what? Right angle. And you guys see what I'm saying? As this line gets bigger, as that angle gets bigger. The only time that it's the same is when we're straight to it, which means we measure what? Right angle. So anytime you're measuring a point, the distance from a point to a line, you always measure that straight to it, which always creates a what? Okay, so with that in mind, what is this saying that the distance from any point to a line is going to be? Well, what do you think the distance from, let's make a E here. How would I measure that? Along a what?
90 degree.
90 degree angle. But I'm going to make a 90 degree angle with what? The ground here, aren't I?
Yes.
So what I'm talking about being the same is that distance and what?
That distance.
Does it not look like those two segments are equal?
Yes.
Well, actually, it doesn't,
Yeah.
Close enough.
but they are. They should be, if I drew the angle correctly. Right here. Those look more the same, don't they?
Yeah.
But not quite.
They look.
That a little more like it.
Yeah.
Maybe you turn it over.
Okay, it could be a little distortion for a
really
while.
cool.
What happens is from any point on this bisector, the straight distance, the perpendicular distance to each side is what? The same. So if I know this line bisects this angle, I know this distance, any perpendicular distance I draw from that point, what are they going to be? The same. Now, as you go up and down here, the distance changes, doesn't it? But it's still the same from that particular point each time. The distance is the same, as long as it's along a what? Right angle. So that's the property I want you guys to remember with angle bisectors.
Can we draw that?
Draw something like it. Go. Try to do your best. You don't have to draw all four of them I had, but draw the bisector and. that was angle bisectors. That's the main thing I want you to remember about angle bisectors. If the distance is equal, it must be on the angle bisector, and if it's an angle bisector, the distance to the sides are equal, right? Okay. What do you think this thing's called?
Crossroad.
Intersect.
It is called
Perpendicular.
Yep.
not quite.
And bisector.
What do you think a perpendicular bisector does?
Exactly what it sounds like.
It bisects.
Bisects
Exactly.
perpendicular.
You know, you remember it's one of those. Remember when you were in grade school and they used to say, "Hey, what is the definition of running man?" And you wrote a man that runs.
No, I don't.
That's
I don't
a,
remember doing that.
That's a festival.
Well, they told you not to do those type of definitions.
Yeah.
Right. You know, use the word itself and just change it around and say that must be a definition. Then get the point I'm making.
Yeah.
Yeah.
Guess what a perpendicular bisector is? It's perpendicular and it does what?
It bisects.
A segment.
Perpendicular.
So this is congruent to this.
You want us to draw that?
Yes.
Already?
So it cuts it in half. And it's what? Perpendicular to it. Pretty simple concept,
Is there
isn't
an
it?
R on the end of perpendicular?
Huh?
Is there an R on the end of
Perpendicular.
Perpendicular.
Perpendicular. I put an R in there and I was looking at his stuff.
How is there a and a B if like that's all the same line?
It's
2 points make up a
What's
line.
the point in the middle?
That's the end of the segments.
Oh.
It's segment AB because
Oh.
you can't bisect a line because it goes on forever and
Yeah,
ever.
that's what I was about to say.
Line L.
You see what I mean?
Yeah.
Line L.
Continues.
Okay, so what I should say here is line L is a what?
Bisector.
No.
No.
Perpendicular bisector.
Perpendicular bisector.
And there is a difference. I could draw, I mean, if I draw a line like that, the edge of this ruler, would that not be a bisector?
It would be just not.
It would be, it's just not a what?
Perpendicular
Perpendicular
bisector.
bisector.
Why?
Because is this line perpendicular to that line?
No.
So it's not a perpendicular bisector. It is a bisector, this line right here is a bisector, isn't it? And of course, I'm referring to the line I'm creating with the ruler. Is everybody okay with that?
Yeah.
That line right here, this is a bisector, but it is not a,
Perpendicular bisector.
this is a perpendicular bisector
It's perpendicular.
because it's perpendicular to that line and it cuts it in half.
So lines can never be bisected. So a
Line can never be bisected, or they're all always bisected because if it goes on forever and ever, where's the middle? See what I mean? All right, everybody got that?
We're rebels.
Why did we go through all that if we're talking about bisectors of triangles? Did I draw even a triangle there?
No.
Oh, I didn't. Now I'm drawing a triangle.
Right.
And what I'm going to do here is I'm going to draw all the angle bisectors. Tell me when you think I've cut the angle in half, or just kind of guessing here. Look at the picture with me.
No.
No.
No. No. No.
I think that's about it, don't you?
No.
A little bit more.
A little bit more. Right.
I disagree.
Oh well, that's fine.
It's fine with me.
What do we write? All the what?
all the angle bisectors.
That's a. No.
Mark it like that to say that's an angle bisector. Okay? Now,
Told you.
angle bisector here.
There. No. Keep it.
Right there. That's fine.
You guys are
Guys, it doesn't need to be perfect.
It has to be perfect.
About right there.
I know I really can't see the other side. Yeah, I guess.
Oh my. I can't get a straight line.
Did you guys see Wreck-It Ralph?
Yeah.
It was a little depressing.
I haven't seen it.
Oh my.
Now, what you will find here, do you think that it's a coincidence that they intersected at one point?
No.
No, it's because you
You
cut
heard
it in
a yes and I
half.
heard a no.
No, because you cut it in half.
That's what I just said.
Maybe he didn't.
Oh wait,
do
is
it,
it
but I wanted
coincidence where
credit.
it's like just randomly happened?
Yeah, just randomly happened.
Oh, okay, then no.
Or do you think that maybe might be something that always happens?
Something that always happens.
If you cut it in
No,
half,
Incorrect.
Ooh.
The angle bisectors are called, can anybody look in when three lines intersect at the same point, or three segments or lines intersect at the same point, what are they called? See if you find the intersection, go! I didn't ask you to guess, I asked you to find an intersection.
Concurrent.
Concurrent lines.
Concurrent lines.
she heard someone else say it. She heard someone else say it.
No, I found it.
I just opened it up to the chapter. That was the first thing I saw.
They are what? How do you spell it? Spell it for me.
C-U-R-R-E-N-T.
Okay.
Why, hey, did she not start?
Oh,
Why'd you interrupt her?
I'm sorry.
Because it's not
Thank you, go C-O-N-C-U what?
R-R-E-N-T.
line, L-I-N-E.
Oh, I think he knows.
Why didn't you let her finish?
Because she never started.
They are concurrent lines. Okay? Meaning they all intersect at the same point. The angle bisectors do. That's kind of neat.
Heck yeah, I was right there.
Is that point called anything? Do they have a name for it? Where the
The
angle
middle.
bisectors
Point of
meet.
concurrency.
Concurrency.
I can spell that.
They call that a point of concurrency. Okay, very good.
Thank you. This is something I
Is there another point? Is there something else they call
Circumcenter.
Circumcenter.
that? No.
Hello.
What is the circumcenter?
The circumcenter is the point of the concurrency.
Of what?
Of the perpendicular
Of the
bisector.
Perpendicular bisector.
Oh, are these perpendicular bisectors?
No.
No.
What are these?
Angle
Bisectors.
Angle bisectors. So what should I call it? You must investigate further.
Investigate.
One more page.
Nope.
2 more pages.
Nope.
Hello.
In center.
In
Alright.
You guys are too slow.
Quiet.
Who cares?
I didn't need any gloating, I just need the answer, and then I need your mouth shut. Thank you, though.
No problem.
The in-center. The in-center is where what?
Angle bisector
bisector.
meet.
Angle bisectors. meet. Okay? Well, wasn't that fun?
Yeah.
Is there anything they say about it? Well, what they say is that because they're angle bisectors at this point, aren't they all equidistant from the side?
Yes.
Okay.
No, hold on. They're not all
Well,
equal.
look at the picture on page 328.
Oh, already there.
Here are the angle bisectors all meeting here. What they're saying is since all of these are on the angle bisector, the distance to each are all the same.
No.
The perpendiculars from there. So, in a different color, just so it turns out, what needs to happen here is what they did in their picture is they didn't finish drawing the angle bisector. You with me? They just drew it to the point of concurrency and then it didn't draw it any further. That's why it's hard for you to see. Isn't this where the perpendicular bisectors meet? I would agree.
Mm-hmm.
What they're saying is that since this is where all of them meet, that the distance from this point to here is the same as the distance from here to this side, and the distance from here to this side. The in-center, so write this, will always be equidistant to each side. So if the distance from here to here is 5, what's the distance from here to here?
5.
5.
Distance from here to here.
5.
5.
It's equidistance from each side. It's, you know, it's exactly right in the middle of where all the sides are. Okay? Does anybody know why that is?
Because you're in the middle of the triangle.
Well, here's the thing about the in-center, what's kind of cool. We'll see if I can get my compass to, oh, I don't think my compass is small enough.
Mm-hmm. Maybe that's not this.
The in-center is basically the center of a circle that's inside it right there. Okay? And the radius of that circle is this perpendicular distance. It's that circle right there. Okay? That's the in-center. This distance here, here, and here is all the same. And that's the radius of the circle with a center right there. Okay? So that's what you need to remember about the in-center. That's what's special about where the angle bisectors meet. That happens. Okay? Now, the perpendicular bisectors. Well, what I'm going to do that is I'm going to try to measure here. Let's see, this side goes to there. 0 to 3, so that'd be 1. Not quite a half, maybe right there. And then let's, does that look like I'm right in the middle?
Mm-hmm.
No, it actually doesn't.
That's 3 to the left.
I did that completely wrong, didn't I?
Mm-hmm.
How long is this thing?
I don't know. 7 and a half.
7.5, so that would be 3 3/4.
Yeah.
Right there. Okay, let's measure, this one. How many marks here? Come on, you guys can do this for me. Tell
What?
Coach Stump where to, go here.
2.
2.
2, and then there's 2 and what? 2 more marks?
2 and 1/4.
So it'd be 2 and 1 mark?
Yeah. not 1/4.
Right there?
Yeah.
Okay.
What are you trying to do?
Put it in the middle each time. Because I'm doing perpendicular bisectors. So this one is 6
Three.
and how many marks?
3, 1.
3 marks. So that would need to be 3 and 1.5 marks,
Or 3 and 2.
roughly right there. So that is a perpendicular bisector right there. That is a perpendicular bisector right there. So that's congruent to that, that's congruent to that. And then if I did this correctly, that should be the perpendicular bisector right there.
What?
I don't know.
That makes no sense.
That does not work.
Anything like what
Correct.
you just said it was supposed to look like.
How did I say it was supposed to look like?
I don't know.
Well,
All I said is that they should meet in the same place, right?
yeah, but on
Yes.
the last one, at least it had.
But that was what? These are what?
Trying.
Angle bisectors. What are these?
Triangle.
Perpendicular.
Perpendicular.
Whatever.
Here I have all the what? Perpendicular what?
That's what that means?
Wouldn't that be all the perpendicular bisectors?
I don't see how that's perpendicular bisectors.
Huh?
Because line right here, line right here, and it.
Doesn't this one cut it in half and
Yeah.
then it's perpendicular there, right?
It's like.
This line cuts this side in half and it's perpendicular.
They're talking about
This
the-
line
they're
cuts
referring to
this
the
one
sides
half
of
and
the
it's
triangle
perpendicular.
as the segment.
And there's parallelism.
Look at the line going like
Now,
this.
watch what happens here. Now, luckily, this should be big enough
Do you see
to where I can, do this. If I did this correctly, see how close I get.
Do we have to draw this?
No. What happened? Where did the circle end up in?
What? That's crazy.
It got really dark. Oh, there it goes.
Where did it end up in?
All the times.
Point.
All the vertexes, right?
Yeah.
Yeah.
That's called the circumcenter.
So that's our whole goal, is to get it.
No, where the,
No, just a fun fact.
where the perpendicular bisectors meet. And this, of course, is the point of concurrency. No, the reason for this, up here, on this one, this point was equidistant from this side, right? That, everybody remember, this is congruent to that, is congruent to that. They would agree.
Mhm.
What's going to be congruent here? Think about a circle. In the
The vertical
circumcenter,
angles.
the distance to each vertex
Could you like?
is the same. This distance right here.
I am confused.
I don't get this at all.
Where the perpendicular bisectors meet is equidistance from each vertex.
Let's just try to understand this.
I am.
Come on, guys.
Circumcenter is what? Equidistant from each what? Vertex of the what? Triangle. The incenter is equidistant from each side of the triangle.
Coach, whenever you're done with this, can you take a picture of it? Because I cannot draw that perfectly in my notes.
Just sketch it.
Really? That or
Or trace
the
it
other
with a
thing?
book.
That?
You don't have to draw the circle.
Circles. I like tracing.
I don't understand.
If now you will all look at
Alright, I got this.
page 326. same thing. Everybody look up here, and you can draw this if you want.
Oh, no.
Okay? Each of these, the solid lines, are each a perpendicular bisector. Do you see that? See how it's perpendicular and what? Cuts it in half. Okay?
Okay, if it's a perpendicular bisector, it has to have two parallel lines, does it not, to bisect?
No, okay, this one is the bisector. Okay, I see what you're, there are three perpendicular bisectors, but this is the bisector for this side. This is the bisector for what? That side. This is the bisector for that side. If you think about it, there's going to be three angle bisectors, there's going to be three segment bisectors. Because maybe that's what I didn't do. That's probably what I didn't do a good job of explaining. That. Think about it. For an angle bisector, how many angles are in a triangle? Three. So there's going to be how many angle bisectors?
6.
No, there's going to be three. of them.
Oh.
Because there's one for each angle, correct?
Yes.
Those three in any triangle always meet at one point, and that point is always equidistant from each side. However, perpendicular bisectors, they will always meet in a point, and they are equidistant from the what?
Bird.
From the vertexes. That is congruent to that, which is congruent to what? That. Make sense?
Yes.
When the perpendicular bisectors meet, you know that distance equals that distance equals that distance. When the angle bisectors meet, here we have angle bisectors, you know this distance is equal to what? That distance is equal to what? That distance. As you see, these are three what? Angle bisectors. Angle bisectors are the same distance from the side, so you measure them along the right angle, right? Well, the perpendicular bisectors are always the same distance from the vertexes, not the sides. That's why this one draws a circle on the inside, and that's why it's called an in-center.
It's all
Okay.
coming together.
You see what I mean? Because it's the same distance there, and it draws a circle inside the triangle. Here, because, and that's why it's called a circumcenter, because the circle circumscribes the triangle. Just like that. See what I mean? That's why, you know, but the main thing to remember is that when the perpendicular bisectors meet, they're equidistant from the what? Vertexes. When the perpendicular bisectors meet, they're equidistant from the sides. So when you're doing problems, like number, it looks like in a lot of these, if you look at number 1, 2, and 3, they want you to recognize that if this is an angle bisector, if that's congruent to that, what does this have to be?
12.
If this is 12, what's this one?
12.
This is a perpendicular bisector, right? So you know that's congruent to that. So wouldn't this have to go at the same, if they come from the same spot? This is 7, what's this?
7.
What about this one?
14. Oh.
If this is a perpendicular bisector, we know it's equidistant from the vertexes, right?
So 7,
So 7x plus 1 equals what?
10x minus 5.
Right? Go down to here. Look. They want to know what CP is. Is this an angle bisector?
Yes.
Because they drew it right there, right? So we know this distance is equal to what?
That distance.
Is this an angle bisector here? Well, we don't know. Wait a second. Yes, we do know because because it's equidistance from each side to it has to be right in the middle. So if this is 23, what's this?
23.
Because those two are the same distance, coming from the same point on the
Wait, what's
bisector.
23? What's the other one?
This one's got to be 23. We know that this is an angle bisector because it's equidistance from the what?
And could you say that it like shares
Sides.
a common side?
No, what I was saying is that, okay, because these two are the same distance, perpendicular distance to each right here, you know that this is right in the middle, meaning that it has to what? Cut that angle in half. So that's 23 and that's what? And the reason is because that's 4 and that's 4.
Is there any proofs on these?
No.
Thank
We're
you.
done with proofs for a while.
God.
What about here? Is this an angle bisector? So what do I know about these two distances?
They're equal.
So this is equal to what?
That, so you're gonna have to solve and make an
You
equation.
see how we're doing?
Okay, so angle
The
bisector.
concept is hard on this, but the actual applying it isn't too bad. Look at these. Look at that. Is this an angle bisector here?
Yeah.
Yes.
Because it cuts it in half. So what do we know about these two perpendicular
They're
distances?
equal.
So if this was 11, what's this one?
11.
See how easy that is? Since these two are equal, what do I know this is? It's got to be a what?
Angle bisector.
Bisector. So if that's 17, what's that one?
17.
So on and so on. See how we're doing the same thing over and over again?
Yeah.
Then you get down to some like
That said proofs.
that one.
Oh god.
They're going to ask you to do a bunch of stuff. You got to figure out what this is. And it says find each measure
Nope.
below.
Nope.
These
Look at
measures
the
are all
37
equal,
and
right? Because
38.
these are all angle bisectors. So if that's 33, what's that?
33.
This is, let's see, if this is, oh, these are fun
Yeah.
here.
No, they don't look fun at all.
I'm gonna have fun
Absolutely.
Why are you gonna have fun?
because I like.
Shut up, Sean.
You're talking to me?
Yes.
Sean. There's more than one
Kid
kid in this class
Really?
named Sean.
We'll do 27 through 28
Oh
tomorrow in
gosh,
class.
you're so stupid.
Your assignment.
B.